Welcome back to Basil's Physics Classroom. Okay, so today we are actually gonna start with a new mini crash series. So by mini crash, what I refer to is, I'll be going through each and every single chapter. We'll be discussing a few questions, something around 12 questions from each chapter every single day. And towards the end of the video, I'll be also giving you some questions which you have to answer and comment the answers below. Okay, and once you do that, I will also provide you with the solutions for that. Okay, so please go along with me every single day so that you can crack the NEET entrance examination. Alright, so let's start with units and dimensions, which will be the chapter of discussion for today. So the first question, the question will be displayed on the screen for you. Right, in an experiment, four quantities A, B and C and D are measured with percentage error 1%, 2%, 3% and 4% respectively. Quantity P is calculated as follows. So quantity P is equal to A cube B square divided by CD. Percentage error in P is. Okay. So here we are supposed to find out what is the percentage error in the measurement of the quantity P. Okay. So I'm sure that you know what is error. So how do you find the percentage error in a given quantity? Okay, as a general expression we can write like this. Suppose we are having something like this. P is equal to A raised to N, B raised to M, C raised to P and D raised to Q. Suppose we have an expression like this. Now to find the percentage error of this quantity, what we do is delta P by P, which corresponds to the relative error or the fraction error, into 100. Delta P by P into 100 denotes the percentage error of the quantity. So this should be equal to, now the next point is very important, the power of A. Magnitude of the power of A I am taking into delta A by A plus magnitude of M delta B by B plus magnitude of P delta C by C plus magnitude of Q delta D by D. Don't forget into 100. So in general, this is a methodology to find the error in a quantity. And this question has been asked for mains entrance examination and even for NEET entrance examination. So this is a very important question and can be repeated once again. So let us solve this question here. So here delta P by P into 100 we have to find out. So that will be equal to, the power of A is what? 3. So 3 into. Now this delta A by A is actually the relative error. And this delta A by A into 100 is what? The percentage error in A. In the question, the percentage error in A, B, C and D are directly given to you. Right? So how do you write it? So we can write it, the percentage error in A. Delta A by A, right? So delta A by A into 100 plus delta power is 2, and put the power, delta B by B into 100 plus, what is the power of C? This one. So 1 into delta C by C into 100 plus power of D means 1 into delta D by D into 100. Right. So what do you get? This is equal to, what is delta A by into 100? It is given in the question, 1%. 3 into 1% plus 2 into 2 plus 1 into 3 plus 1 into 4. So what do you get? 3 into 1, 3. 3 plus 4, 7. 7 plus 3, 10. So the answer will be 14%. So the answer for the first question is 14%. So we have found out what is the error in the quantity P measured. And if we know the values of A, B, C and D, the percentage errors in A, B, C and D, we can find the error. Okay. So I hope the question is clear. Is it clear? If you have any doubts, do feel free to comment below. Okay. Now let's move on to the second question of discussion. Right. So the second question is on displayed on the screen. Please read it. And the question is, if force F, velocity V, and time t are taken as fundamental units, then the dimensions of mass are. Dimensions of mass we are supposed to find out. So what are the basic three fundamental quantities that we usually take? The three basic fundamental quantities. We have actually seven fundamental quantities, right? So out of that, we usually do the problems using M, L, and T. We have again candela, Kelvin for temperature, and everything we have it for current. Those are fundamental quantities, right? So MLT we usually write in terms of MLT. But in the question it is told that the fundamental quantities are force, then we have velocity, then time. Three fundamental quantities are given to you. One is force, the other is velocity, the other is time. So how do you solve this question? We are supposed to find out what is the dimensional formula for mass in terms of F, V and T. Okay, there are actually two methods to solve this. One, the basic and the general method, and two, a shortcut method. So I'll show you both and you can decide on which one you want to use. Alright, so it is given that in the question it is told that the mass M depends on the force. It depends on the force. So I'm putting a power. We don't know what is the power there. I'm putting a power as x. Velocity, putting the power as y. And time, putting the power as z. Okay. Now for this, the next step is writing the dimensional formula of all the corresponding quantities. So for mass, I'm going to write m raised to 1, l raised to 0, t raised to 0. Okay. So this will correspond to what? Will correspond to what is the dimensional formula for f? For f it will be f ml t raised to minus 2. And the power is what? The power is x. What is the dimensional formula for velocity? Velocity dimensional formula is lt raised to minus 1. So lt raised to minus 1 and the power is y. Now time itself, that's the dimensional formula, right? Now the next step is compare the powers of m, l and t. Okay. Now from the LHS side, in the LHS side we have, what is the power of m? The power of m is 1. So 1 equal 2. In the RHS side, in both these quantities there is no m there. But in this quantity there is an m, right? So what is the power of this m? Here it is 1 raised to x. So it will be x. So you got the value of x. X is equal to what? 1. Now, next term we'll take, come by the power of L. So the power of L in the LHS side is 0. So 0 equal to RHS. We have here an L raised to x. So x. Here the power is 1y. So plus y. Okay. And we already know what is x, right? What is x? 1. So substitute it over here. So you get 0 equal to 1 plus y, or y is equal to minus 1. Clear? Now, to find the power of z, t. So in the LHS side, t has the power of 0. So 0 equal to, here there is a minus 2 here, minus 2 into x. So minus 2x. Here there is a minus 1 here, so minus 1 into y, minus y. Okay, and here the power is, as you can see, 1. I'm sorry, we forgot the z over there, the power is z. Okay, so 2 minus 2x minus y plus z. Now we know the value of x, we know the value of y, now substitute. So you're getting 0 equal to minus 2 minus 1 plus z. So that will be what? Z is equal to, plus it becomes plus 1, minus 2 plus 1 is minus 1, it is other side, z is equal to 1. Okay, so what do you get the answer as? You got the power of x, y and z. So you can write this is proportional to f raised to 1, v raised to minus 1 and t raised to 1. So the answer is f raised to 1, v raised to minus 1, t raised to 1. That is the answer for the question. Okay, is it clear? And the option is, you can find the option from there, right? So f raised to 1, v raised to minus 1 and t raised to 1. Okay, now this actually is a long method and you cannot always complete this method in a single minute. So I'll teach you a very shortcut method for that. Okay, so I'll teach you how to do it in a shortcut method. Now, just think about the quantities that are given here. We have force given, velocity given, time given, mass given. We are supposed to relate mass, force and velocity and time, right? Now think of a relation connecting force and mass. Anything that comes to your mind? What is that? Yeah, Newton's second law, right? What was that? F is equal to ma. So F is equal to ma. What was it? Acceleration. So you can write this as m is equal to F by a. Any problem? Okay. And what is acceleration actually? You have learned that it is a change in velocity with respect to time. Or simply, based on dimensional formula, we can simply write it like this. F is equal to v by t. Right? So now look here, t goes to the numerator. This will be f, t goes over here. And what is the dimensional formula of t? T. So v comes to the numerator again, becomes v minus 1. So f v minus 1 t, which is the same answer that we obtained earlier, right? So this is also a very useful method in solving many of the questions because it saves you time. So in this method, you have to think about a relation connecting all those quantities and then solve it. Okay, so is it clear for you? So dimensional analysis is a very important topic. You're gonna get a lot of questions for your exam. There's a probability of getting question for your exam. I cannot say a lot of questions because if you analyze the previous papers, we can just see one question in each of the papers from units and measurements. Okay, so the probability is for one question, but you may get two questions also. Okay, depends on a lot of factors. All right, so is it clear? Right? So let's move on to the next question then. Okay, and you can read the next question on the screen. So the third question. The third question is, in dimensions of critical velocity we see of liquid flowing through a tube are expressed as eta raised to x. What is this eta value? It is actually coefficient of viscosity, is the density of the liquid. And what is r given there? R is the radius of the tube respectively. Okay. Then the values of x, y and z. We are supposed to find the values of x, y and z. Right. So values of x, y and z. So let me show you the general method for that. So critical velocity depends on which all quantities? It depends on eta raised to x, rho raised to y and r cube. Right? So for doing this question, you have to learn the dimensional formula for viscosity. Okay, so please make sure that you learn the dimensional formula for quantities like mu 0, epsilon 0, g and etc. And this eta and everything, you have to learn it. Okay, without learning there is no other way. Right. And there is actually one other method to solve it. Suppose you know an equation connecting eta and some other quantity. Maybe this equation, the Stokes law, F is equal to 6 pi eta RV. Now here r is the radius, v is the velocity, f is the force. If you are aware of this equation, then you can actually find out eta from here. Okay, but if you can learn it, well and good. So coming back to the question. So Vc proportional to eta raised to x, rho raised to y, r. Now how do you solve it? So let's use the same method we adopted earlier. Let's write the dimensional formula. Okay, so Vc means it's a velocity. So m raised to 0, Lt raised to minus 1 corresponds to eta. What is the dimensional formula of eta? It is m L raised to minus 1, T raised to minus 1, raised to x. Density, it's mass by volume, right? So that will be m L raised to minus 3, the whole raised to y. And for r, it will be what? It's r raised to z, okay? For r, it will be length, L raised to z. Okay, now let's solve it. So now what is the next step? Look at the powers, equate the powers, right? So what is the power of m? What is the power of m? Power of m is 0. 0 equal to. On the RHS side, what is the power of m? Let's see. What is the power of this m? There's a 1 here, right? X. and here there is another m raised to y. So this plus y. We don't know the value of x or y. We cannot get the answer from there. Now let's form another equation. What is the power of L here? It's 1, right? So 1 is equal to, in the RHS side, write the powers of L. Here it is minus 1 into x. So minus x. Here it is minus 3 into y. So minus 3y. Here it is simply z plus z. Again. Now one more equation. T raised to minus 1. In the LHS side, the power of t is minus 1. That's equal to the RHS minus 1 into x minus x. Here there is no t term there. Here also there is no t term there. So from here, what is the value of x? X is equal to 1. Substitute that 1 over here. So what do you get? 0 equal to 1 plus y, which implies y is equal to minus 1. Right? Substitute x and y over here, and we get 1 is equal to minus 1 minus 3 into minus 1 plus z. So what are you getting? Minus 1 plus 3. What is minus 1 plus 3? Minus 1 plus 3 is 2. So that 2 you can take it over here. That will be z is equal to minus 1. So you're getting x, y and z. Right. So what is the answer? Tell me what is the answer? Yeah, VC will be equal to eta or proportional to eta raised to x is what? 1. Rho raised to what is y? Minus 1. What is r? Minus 1. Okay. So you can check the options and tell me the answer. Which is the correct answer? Correct answer is option. Tell me the option after checking. Okay. Right. Let's move on to the next question now. So next question number 4. It's again a question on dimensional analysis. And the fourth question is on the screen. So the question is, if energy E and velocity V and time T are chosen as the fundamental quantities, the dimensional formula of surface tension is. So you are supposed to find out the dimensional formula for surface tension. Okay. Now again, this is a question we have to solve using the dimensional analysis method. Right. This is again a previous year 2015 question. So how do you solve this? So you can actually use the shortcut formula I taught you just before. So surface tension dimensional formula we are supposed to find out. Right. So we know that surface tension is equal to surface energy divided by area. Surface tension is equal to surface energy divided by area. Now in case you have any doubts how this equation came, just look here. We know that surface tension is equal to force by L, right? So just multiply with an L in the numerator and denominator. So what do you get? Force into length or force into displacement. What is that? Work done, right? So work done is actually equal to the energy. So energy by L square. What is L square? Length into length. It is the area. So area. So that's how we get that. Okay. So here this can be written as this is equal to, that's equal to energy divided by A. Okay. Now energy is already given to you in the question itself. A term is not there. So we have to write A in terms of velocity and time. Okay. We have to write A in terms of what? Velocity and time. We have to write A in terms of velocity and time. How do you do that? So let's see here. We know that velocity and time, right? So velocity dimensional formula we know. Just write the unit first. Meter per second. Time, second. Now suppose we multiply V and T. What do we get? What do we get? We get M, right? This s raised to minus 1 just gets cancelled out. So, but we are supposed to get a unit of meter square here, right? Because the unit of area is what? Meter square. So how do you get meter square? Velocity into time, the whole square, right? Velocity into time is meter. So velocity into time whole square is what? Meter square. That is area. So this is equal to E divided by V into time, the whole square. Or you can write this as E V raised to What will be the corresponding dimension formula? E v raised to minus 2 t raised to minus 2. Clear? So without using the method of dimensional analysis, we are easily solving this. Okay, so remember this shortcut method. Okay, so e v raised to minus 2 t raised to minus 2. In case you are unable to think of a equation connecting all those quantities, I think you can go for the general method. Okay, if you can relate those, go for the shortcut method always. It saves a lot of time. Okay, alright. So now, shall we go to the next question? Okay, right. So the next question number 5. Question is on the screen again. Please read the question. There's a question from screw gauge. And the question is, a student measured the diameter of a small steel bowl using a screw gauge of least count 0.001 centimeter. Okay, so the least count, let me write here. Least count is equal to 0.001 centimeter, or that is equal to what? 0.01 1 centimeter is equal to how much millimeter? 1 centimeter is equal to 10 millimeter, right? So converting into millimeter, it will be 0.01 millimeter, right? So least count is given. Now suppose the least count value is not directly given. How do you find the least count? To find the least count, we have a formula. Least count is equal to pitch divided by the number of circular scale division. What is the formula? Pitch divided by the number of circular scale division. Okay. Now pitch means when we are rotating, suppose the screw gauge is shown on the screen. You can see a circular scale also there. Now suppose the circular scale is rotated. Upon one complete rotation, the distance moved by the circular scale along the main scale. I repeat, upon one complete rotation, the distance moved by the circular scale along the main scale, that we call it as a pitch. A number of circular scale division, you can just, the number will be there on the screw gauge itself, or it will be given to you in the question. And pitch term will also be given to you, so no worries regarding that. So even if the least count is not directly given, you can use the formula to find the least count. Okay. Now moving on to the next part, what is given in the question. The main scale reading is 5 millimeter and 0 of circular scale division coincides with 25 divisions above the reference line. So what is the main scale reading? MSR is equal to 5 millimeter. What is the main scale reading? 5 millimeter. Okay. And what is the coinciding division? That is 25th division is coinciding. Okay. Now, the general formula for determining the reading of a screw gauge is reading is equal to main scale reading plus least count into coinciding division. I repeat, formula is main scale reading in plus least count into coinciding division. So let's find the answer. Main scale reading is what? 5 millimeter plus least count is what? Least count is given as 0.01, so 0.01 into 25. So you're getting 5.25 millimeter, right? But don't forget the last part of the question. What is in the last part of the question? It is said, if the screw gauge has 0 error minus 0.004 centimeter, the correct diameter of the ball. So there is a 0 error. When there is a 0 error, we can find the diameter like this. Diameter will be equal to reading, which is our R here, right? I'll just write R, which is our R minus the 0 error. R minus the 0 error. So that is equal to 5.25 minus 0 error is given as what? 0 error is given as? What is the value given? That's equal to minus 0.004 centimeter, right? That is minus 0.04 millimeter. Substitute minus 0.04 millimeter, and you're getting it as 5.29 millimeter. 5.29 millimeter. Okay, so when you learn the chapter units and dimensions, you should never skip the topic of screw gauge and vernier calipers. A question from vernier calipers also we'll do today. So never ever skip that portion because it's a short question. Short question means if you get a question like this, you will surely get the answer. There is no complications or anything. Just follow the procedure, step-by-step method. Okay, so please make sure that you practice some more questions related to screw gauge and vernier calipers. Okay, right? Okay, so shall we go to the next one now? Right, okay. So the next question, and that is question number, what is question number? Question number 6, right? Okay. Now the next question is on the screen. S is equal to A into 1 minus e raised to minus bxt, where S is speed and x is displacement. X is displacement. The unit of bs. The unit of bs. Okay. So one thing you have to remember here is, here we have to apply the principle of homogeneity there. Now homogeneity direct principle we don't have to apply here. Because here it's even easier to do this. Okay, let me tell you how to do this question. Now, based on principle of homogeneity, since I mentioned homogeneity, I will tell you what it is. Suppose we have an equation like this: S is equal to ut plus half at square. I'm sure that you're familiar with this equation, right? Now, for an equation to be valid, it is very important that it should be dimensionally correct. Okay, it should be dimensionally correct. The dimensions of the LHS must be equal to the dimensions of the RHS. And also, if we have to add two quantities, we can add two quantities only if the dimensional formula of this is equal to the dimensional formula of this. Which means the dimensional formula of this should be equal to the dimensional formula of this, should be equal to the dimensional formula of this. Okay, so that is actually the idea behind principle of homogeneity. Okay, now here to solve this condition, remember that the power of an exponential, it should be a dimension-less quantity. The power of the exponential should be a dimension-less quantity. Similarly, if you are writing log and inside the log there is something given in the question, inside the log also the quantity should be dimensionless. It should be a constant. It should be dimensionless. Okay, so e raised to some quantity, if you write, it should be dimensionless. Inside log also the quantity should be what? It should be dimensionless. Clear? Right. So here the power of e should be dimensionless, I said. So now let's see the terms over there. We have a b, we have x. What is x? Displacement, right? So unit of displacement is what? Meter. We have a time. Second, right? So I told you that the power of the exponential should be dimensionless. Already there is meter and second, right? So already there is meter and second. So what should be the unit of b so that this meter and second gets cancelled out? What should be the unit? It should be, yeah, it should be m raised to minus 1, s raised to minus 1. So what happens? If this is m raised to minus 1, s raised to minus 1, this term will not have a unit. bxt should not have, and here if we write m raised to minus 1 and s raised to minus 1, it will not have a unit. So the correct answer for this question will be what? The unit for b is meter raised to minus 1, s raised to minus 1. The correct unit for that quantity will be meter raised to minus 1 and s raised to minus 1. Are you able to follow me? Clear? Right. Okay. Now let's move on to the next question. The next question is on the screen and I'm repeating again and again. In case you have any doubts, please do comment below. Okay. I'll be very happy to help you out regarding the questions. Right. Now the next one. The next question is, if L and R are respectively inductance and resistance, then dimension of L by R will be. It's a simple question actually. Dimension of L by R, they are asking you. Dimension of L by R. Now, tell me, have you heard this term L by R somewhere? L by R. RC, anything? Have you heard? Able to recollect? L by R is what? L by R is known as the time constant. In an LR circuit, you're defining this time constant, right? So time constant, L by R is actually a time constant. Suppose they're asking you RC, again, that's a time constant, right? So here, L by R is actually the time constant. So time constant means the dimension should be what? What should the dimension for tau? It should be T. Or we can write as M raised to 0, L raised to 0, T. So dimension of L by R will be what? The dimensions of the time constant, which is M raised to 0, L raised to 0, T, or simply T. Clear? Any doubts there? It's a very simple question. Okay, but remember that what is L by R? But otherwise you will get confused there. Okay. Alright. So that is first question number 7. Right? Shall we move on? Okay. So the next question now. Question is there. Density of a liquid in CGS system is 0.625 gram per centimeter cube. What is the magnitude in SI system? What is the magnitude in SI system, they're asking you. Okay. Again, the method of dimensional analysis. So dimensional analysis they uses actually. 1. To check the correctness of an equation. 2. To derive a physical relation. And 3. To convert one quantity into another. The third use we can apply here. So how do you solve it? So here, CGS system, a quantity is given, right? 0.625 gram per centimeter cube. It convert into SI system. So CGS to some SI system. So we can write N1U1. N1 is the numerical quantity, U1 corresponds to a unit. Should be equal to N2U2. To easily understand that, 1 centimeter is equal to what? 10 millimeter, right? The same thing. 1 centimeter is equal to 10 millimeter. That's the same thing. Way of writing it. So N1U1, I'm going to write N1, 0.625 U1 gram per centimeter cube, right? I'm going to write in terms of the dimension there. So I'm going to write M1, L1 raised to minus 3. Centimeter goes to numerator, it will be minus 3. Gram per centimeter cube. This is equal to N2. We have defined N2. M2 L2 raised to minus 3. Right? I'm taking this term over here. It will be 0.625 M1 by M2 and L1 by L2, the whole raised to minus 3. Fine. That will be equal to what? M2. Now, what can we do here is M1, it is actually in gram. In SI unit, what is the unit for our mass? It is kilogram. And for length, it will be meter. So I'm writing it like that. 0.625 M1 is gram by M2 is what? In kilogram. 1 kilogram is how much gram? It is equal to 10 raised to 3 gram. By L1 centimeter is given, centimeter by L2 corresponds to in meter, right? SI unit, it is meter. And 1 meter is equal to 100 centimeter, 10 raised to 2. Minus 3. That will be equal to M2. Okay, so now how do you get the final answer here? So gram and gram gets cancelled. This and this gets cancelled. This goes to the numerator. That will be 10 raised to minus 2. 10 raised to minus 2 raised to minus 3. That will be 10 raised to 6. Right? So N2 will be equal to 0.625 into, this goes to numerator, 10 raised to minus 3 into 10 raised to 6. Now that is equal to 625. So the value of N2 when we are converting from CGS to SI system will be 625. Clear? So the density of the liquid in SI system, the value, the numerical value is given by 625. Okay. So we have used the method of dimensional analysis here to convert one quantity into another. Right. Now if you want to avoid all these steps, what you can simply do is this gram value, here itself in this value 0.625 gram per centimeter cube it's given, right? Right. So here we can just substitute, instead of gram you can put in terms of kilogram, you can put the value, and the centimeter you can actually write in terms of meter. Then also that is another way of finding the answer. But this is also a simpler way. It doesn't take much of a time once you are familiar with the method. So that is our question. Is it clear, everyone? Any doubts regarding that? Okay. So we shall move to the next one. From the board, the number of significant figures in all the given numbers 25.12, 2009, 4.156, 1.217 10 raised to minus 4 is. Now, to solve this question, you'll have to know what are the rules governing significant figures. That is, how do you find the significant figures? So there are certain rules there. Okay, I'm actually giving you the rules on the screen there. So please refer with your NCERT textbook and do learn the rules. Okay, I'm not telling you all the rules right now. So here in the first term, even though there is a decimal, all the non-zero digits are significant. That's the first one. Remember that all the non-zero digits are significant. Okay, that's the first rule. So how many significant figures are there? 1, 2, 3, 4. 4 significant figures are there. Fine. And here there are 2 zeros in this number. Okay. Another rule is zeros which come between 2 non-zero numbers are significant. Zeros which come between 2 non-zero numbers are significant. So here how many significant are there? 2, 0, 0 and 9. So 1, 2, 3, 4. Again 4 significant figures are there. Okay. Now the next one again, all are non-zero numbers. So how many significant? 4 significant are there. Okay. Now in the next number, when you are finding the number of significant figures, you don't have to take this into account. That you don't have to take into account. So the remaining portion you have to take there. How many significant are there? 4 significants are there. Okay. So in the question, in all the 4 numbers, how many significant figures are there? 4. And that is the answer for that, 4. Now suppose we have a number like this, 0.003. How many significant figures are there? Remember, to the left side of the decimal and the right side of the decimal, if it is a 0, those zeros are not significant. The zeros appearing on the left side and the right side of the decimal are not significant. Okay, so here there is only one significant figure, that is 3. There is only one significant figure. Okay, but if there was a 1 over here, what will happen? We have learned in the first condition, all the zeros between 2 non-zero numbers are significant. If there was a 1 here, there would be 1, 2, 3, 4, 5. 5 significant figures. Understood? Right. Okay. So these are some of the laws corresponding to the significant figures. Right. So I hope it is clear for you. Right. Okay. Now let's move on to the next question. And the next question is on the board. In a vernier caliper, this question from vernier caliper, one main scale division is x centimeter and n division of vernier scale coincide with n-1 division of main scale. The least count of the calipers. We are supposed to find out the least count of the calipers, right? So how do you find the least count of the vernier caliper? And there is a simple basic formula for that. Least count of a vernier caliper is given by least count is equal to 1 MSD minus 1 VSD. What is MSD? MSD means it is main scale division. What is VSD? VSD is vernier scale division. Okay, MSD is main scale division, and what is VSD? It is vernier scale division. Okay, so 1 MSD minus 1 VSD gives you the least count. Now in the question there is a condition given there. It is said that n divisions of vernier scale coincide with n-1 division of main scale. So n division of vernier scale coincide with n-1 division of main scale. n-1 division of main scale. So you can write 1 VSD from here. 1 VSD will be equal to n minus 1 by n MSD. I'm just taking this n over here. Fine. So you can substitute this condition over here. So we'll be getting least count is equal to 1 MSD minus n minus 1 by n MSD. So cross multiply and simplify, you'll be getting n over here. So n minus n is gone. So minus minus plus. It is MSD by n. This MSD by n. So that will be equal to what? MSD by n. What is MSD given? MSD is given as x, right? So that will be x by n. It will be x by n. So we have used the method to find out the least count, and this is again a previous question. And in some cases, a question may come. They may actually say something like 16 vernier scale division coincide with 19 main scale division. Something like that. Now, this is actually not possible. So, something like that may come. Or 8 vernier scale division may coincide with 10 main scale division, or something like that. Okay. If in the question something like that comes, apply the same method, no difference at all. Find VSD from here, substitute it over here, simplify, you get the answer. Okay, to find the least count. Now, suppose you are asked to take the reading using a vernier caliper. Now, the method is very same, similar to that of the screw gauge. Reading is equal to main scale reading plus the least count into coincident division of the vernier scale. That is only change. Okay, and all those data will be given to you in the question. So, using the same methodology you adopted in screw gauge, you can actually find the reading using a vernier scale also. Clear? Okay, right. So now we are moving on to the next question now. Question will be, the value of two resistors are R1 equal to 6 plus or minus 0.3 kilo ohm and R2 equal to 10 plus or minus 0.2 kilo ohm. So the resistance are given there. The percentage error in the equivalent resistance when they are connected in parallel. We are supposed to find the equivalent resistance. How do you find the equivalent resistance? We know that when two resistors are connected in parallel, equivalent RP is equal to what? R1, R2 divided by R1 plus R2, right? R1, R2 divided by R1 plus R2 when two resistors are connected in parallel. So here we are supposed to find the error, right? Percentage error. So that will be delta RP by RP will be equal to delta R1. Remember the first method I taught you in the first problem. Here the power is 1. Everywhere the power is 1. Here also the power is 1. So delta R1 by R1 plus delta R2 by R2 plus delta R1 plus R2 divided by R1 plus R2. Okay. So this is equal to, what is delta R1? 0.3 by 6 plus 0.2 by 10 plus R1 plus R2. So that is delta of R1 plus R2. 0.3 plus 0.2, that will be 0.5 by R1 plus R2 will be 6 plus 10. So that will be 16. Fine. So solving, what do you get this as? This is equal to 0.10125. Okay. Now we are supposed to find the percentage error, right? So percentage error will be what? Delta RP into RP by RP into 100. So percentage error will be this into 100. So that is equal to 10.125 percentage. 10.125 percentage. Now this question has actually come for KEAM once, and also there's a probability of you getting this question. Now similar question is also there near NCRT. Okay, right. So that is why I discussed this question. Okay, is it clear? I hope it's clear for you. Okay, so shall we go to the next question? All right. So the next one is again a question from us. Alright, the question is on the screen. The period of oscillation of a simple pendulum is T is equal to 2 pi root of L by G. Measured value of L is 20 centimeter, known to 1 millimeter accuracy. So remember that if in the question error is not directly given to you, the accuracy, the resolution, the least count, everything is actually the value for the error. Okay. Now least count we can call this error. Why? Because when you take a device, suppose you're taking a scale and the scale can only measure a normal scale, not a scale or something that we use in our classes, we only measure 0.1 centimeter, right, or 1 millimeter. So if you want to measure something lesser than that, the scale cannot do it. So we treat it as the error. Okay. So the least count is actually the value for the error. So if error is not given, you can use the least count as the error. Okay. So now the measured value of length L is known to 20 centimeter, known to 1 millimeter accuracy, and time for 100 oscillation of the pendulum is found to be 90 seconds. Using a wristwatch of resolution 1 second. The accuracy in the determination of G. The error, percentage error, we have to find out. That's the same thing. Okay. So from here, I can actually square on both sides. You get T square proportional to L by G, or G proportional to L by T square. Fine. And this can be written as we have to find the percentage error there. Delta G by G into 100 is equal to delta L by L into 100 plus 2 into delta T by T into 100. I hope it's clear why I only write 2 here, right? It's the magnitude of the quantity we are doing, the power. So that's equal to, what is delta L? 1 millimeter. So 1 millimeter by L is actually 20 centimeter. So 20 centimeter means how many millimeter? 20 into 10 millimeter into 100 plus 2 into time is given 90 seconds and resolution 1. So 1 by 90 into 100. Okay. So solve this. Millimeter units, everything cancels out. So what do you get? You get 0.0222 plus 0.005. Now that is equal to 2.7 percentage. That's equal to 2.7 percentage. But in the options, you cannot see a 2.7 there. So it will be approximately, you can take it as 3 percentage. Okay, 3 percentage. Okay, so it's again using the methods of error to find the error. So I hope you are able to follow the questions I have taught you in the class. So in units and dimensions, the main portions you have to take care is, one is about the dimensional analysis part. I taught you 3 main uses for that, the dimensional analysis. Then about the significant figures, rounding off and everything, order of magnitude and everything. And also towards the last part, errors. And one more thing, vernier calipers and screw gauge. So these are the things you have to take care and learn before you go for the examination. Okay, so towards the end of the video, I'm actually giving you some questions. So I'll give you like maybe 1 day time, and don't use the full 1 day. Okay, you can just use like 1 hour or something. Solve the question and comment the answers below. And once, if anything is not clear, also don't worry, I'll provide you with the solutions once you comment the answers. Okay. All right. So till we meet tomorrow with the next chapter, that is one-dimensional motion. Thank you.